Okay, we're going to study factorization. All right. So specifically, factorization for quadratic equations like this. Um, Quadratic equations are equations that have up to power 2 on algebraic terms. So you have an equation where you have something like x raised to power 2 plus something something here, then an x, and then a constant that's just a number without any x by the side, plus minus constant here. You know, is an equation if there's an equal sign something. So anything above power 2 is no longer called an equation. It's now more like a polynomial. Alright, so for this lesson, we'll factorize quadratic equation. That's maximum of power 2. Okay. And let's look at let's look at it this way. Um, Factorization is just a way of taking you back from whatever you get from an expansion. And in expansion, let's say for example you have x minus 4, right? And then you have x plus 9. If we should expand this, let's say x times x squared, then we'd say x times 9, this x again times 9. We've done x times x, now x times 9. We have 9. After that, we'd say minus 4, the next number, times x, have minus, say, minus 4 times 9, minus 4 times 9. Alright, now this is an algebraic equation. I've put this. So this is a quadratic equation. And if we are to factorize this, let me simplify it a little by bringing these two together. So I have x squared plus 9 minus 4 is plus 5, 5x, and then minus 36 whole squared. Now, if we want to factorize this, we need to get what we call the sum of roots. The roots are actually two numbers you need to bring sum on, and their sum should be equal to this. Whatever is standing beside x, that's coefficient of x. Coefficient of x is different from coefficient of x raised to the power 2. Whatever stands here is coefficient of x raised to the power 2. In this case, coefficient of x raised to the power 2 here is just 1. As you can see, there's nothing there, it's 1. Alright? So, for sum of roots, both x and its coefficient with its sign is what you want to get when you add these two numbers that you're going to bring. And then, product of roots, you have to multiply these two with their signs. This one with the sign, since there's no sign here, is positive, multiplied by this one with the sign. The sum should be 5x. Product should be x squared times minus that. So the product should be minus 36x squared. This is what we want to get after multiplying two numbers that we don't know yet. Okay. Now, looking at this, you want to get 5, positive 5 when added, and you want to get negative 36 when multiplied. You just know that there will be two numbers because there's a negative sign here. One will be negative, one will be positive. That is a kind of short way I used to think about it. I know that one will be negative because minus plus is the reason we're having this minus multiplied. But when we add, we have a positive answer. It means the positive number will be bigger than the negative number. And the difference between the positive number and the negative number will be exactly this 5 here. Okay, so I'm thinking of a number that um, I'm thinking of a number that is positive and another number that is negative, and the difference between them is 5. So if I say 6 times 1, because when I say 6 times 1, I mean plus 6 times minus 1. Doing that at the back of my mind, I know this is minus 6, so it won't work. I'll increase this to plus 7 times plus 2. I know the negative number must be smaller because when you add, you have a positive. Yeah. So let's go. I'll do minus 14 at the back of my mind. Of course, that will not work. I'll increase this to plus 8 and this to minus 3. Mm, no, that will not work. And I'll increase this to plus 9, this to minus 4. So I'm increasing them by 1, maintaining that difference of 5. And this works because 9 times 4 is perfectly 36. So these are the two numbers I want. So what would I do? I'll replace this sum by the two numbers. So I'll write x squared. Instead of writing plus 5x, I'll write plus 9x minus 4x. Do you know that 9x minus 4x is 5x? Exactly. So I didn't change anything. Still the same. And minus 36, just like it is here, equals 0. Realized we just went exactly. That's what factorization does, like I said earlier. It takes you back. So you look at this and this. What is common between these two? X, right? And x, right? Then x times 4 to give you x squared, x. X times 4 to give you 9x plus 9. Put that down. You want to do this in such a way that the next bracket is having exactly what is here. So this bracket and the second bracket you're about to create when you look for something common between minus 4x and minus 36, you want to have something like this in the bracket. Just go ahead and write x plus 9, close the bracket. Now think of something you put out here, multiply with x, and get minus 4x. Answer is minus 4. If you do this right, this will just work automatically. You know why? You actually thought of two numbers perfect. So having done that, you take the numbers outside, put them into one bracket, right? And then the numbers inside are the same. So one bracket. Why am I taking the number outside into one bracket and the number inside into one bracket? Remember when we were here, we did this times everything here. It's like this guy is outside. Then this times everything here. So what we were doing when we expanded this was basically this. This is what we did when we expanded this. We multiplied x by this and x by that. That's what you did. X times this, x by that. Then you start with minus 4. Minus 4 times this, minus 4. So expanding things, writing this way or this way is exactly the same and correct. Okay. So you see we have factorized it back to the way it was originally. Alright? And one of the uses of factorization is you can use it to find the possible values of the unknown. So we can now equate each of these brackets to 0. We can say x minus 4 equals 0. So x is 4. Then we can say x plus 9 equals 0. So x is minus 9. These are the two possible values of x that you can put here. Alright? You can put here and actually get 0. Alright, let's do another example that is kind of different in the sense that I want us to have a coefficient here in front. Alright, let's try one of the ones I have here. It's written this way. 21v for that example. 21v equals 8v squared, right? Minus 9. Okay, so here we might need to do a little arrangement first before we start. So that it looks like what you're used to. Putting the the value of the algebraic term with power 2 first, like it is here. So say 8v squared first, and then we take this across. So 21v across becomes minus 21v, right? Minus 9 remains where it is. So this becomes 0. Alright. Now the sum will be this with a sign here. Alright, so our sum is minus 21b. Product now will be this times this. The difference is here it was just 1. So now you get to appreciate the idea of multiplying the coefficient of v square in this case. The first example is x squared. So let's go. We're having v squared, 8v squared for product. We have 8v squared times, what do we have here? Minus 9. And 8 times 9 is 72. So we're using 72 squared. Alright. Now to finish this off, we have to think of two numbers. We add them, get this, minus 1v, multiply them, get 72v squared. Well, minus 72v squared actually. So we have a negative product and we have a negative sum. Well, the only way this can work is negative product, negative sum. One is negative, one is positive. Two numbers we are looking for, one will be negative, one will be positive. But in this case, the negative one will be bigger than the positive one. It has to be bigger by exactly 21. So it's more like the negative one could be 20. 1 plus 1, let's say minus 2. And then the positive one will be just 1. Okay. Now this will work as 1 is just b. This will work for the sum, but will not work for the product. So let's add 1 minus 23 and 2b. Still work for the sum, but 46 is what we'll get if we multiply 23 by 2. So let's go again, minus 24v times 3v. I think this gives us 72. Perfect. So we've got our two numbers. So what we have to do now is write 8v squared, alright? Then we'll put minus 24v, then minus plus 3v, and then minus 9. Then we look for something common between 8 and 24. We know that is 3. Right? We take 3 out. Apart from that, v is also common here. Put v in a bracket. Put v outside the bracket. What do we multiply? Sorry, 8v is actually common. I was thinking, because I know that 8 times 3 is actually, okay. So I know I just need v in here to get 8v squared, and I need minus 3 here to get this done. Okay, for my second bracket, I know I'm going to have exactly the same thing, 8v minus 3, right? I'll just put that down. If I start thinking of what would I put out here? Sorry, we're going to have v minus 3. That's it. So what would I put out here to get 3v? 9. Of course, a positive 3 would be job, so plus 3. Alright, so like we did here, I would say 8v and the plus 3 that is out there, put them into one bracket. Then this bracket is exactly the same. And yes, I have factorized. I can go on to equate each of them. Minus 3 was supposed to be an equal sign. It's supposed to be minus 3. Sorry, plus 3 equals 0. Get 8 equals minus 3. One of the possible values. one for this other one. V will be equal to 3. These are the two possible values. Minus 3/8 actually. So these are the two possible values for V. Alright? But these